History. Satellite navigation owes a debt to Sputnik, the Soviet satellite launched in 1957. U.S. scientists learned they could track the satellite by listening to changes in its radio frequency. The Navy's transit navigation system was developed in the 1960s, which relied on 6 satellites and was designed for use by submarines. Meanwhile, engineers Ivan Getting and Bradford Parkinson began leading a Defense Department project to provide continuous navigation information, leading to the development of Navstar GPS, now known as GPS, in 1973. The military launched the first GPS satellite in 1978 and completed the system in 1995. GPS uses a constellation of 24 satellites orbiting 12,000 miles high, each circling the globe every 12 hours. Military uses. Other than for standard navigational purposes, the military uses GPS for bomb and missile guidance. Since the 1960s, development of precision-guided munitions has been a focus of weapons development. Satellite-guided weapons are now one of the weapons of choice as they can be used in all weather conditions without being adversely affected. The most common precision-guided weapon is the Joint Direct Attack Munition, or JDAM. The JDAM is actually a guidance kit that converts standard gravity bombs into smart bombs. The JDAM uses a combination of GPS and inertial guidance systems. The JDAM will operate on its own once deployed and navigates toward the target by using programmed coordinates. Recreational use. Modern global positioning systems have evolved and are beginning to replace traditional navigation methods to aid us in reaching our destinations. GPS can help ensure that you are able to find your way along a difficult trail or path, and more importantly, find the way back. GPS receivers, in conjunction with features like tracking and breadcrumbing, can help hikers to navigate the terrain more effectively. Devices from one of the major manufacturers, such as Garmin or Magellan, are typically used for hiking or backpacking. Additionally, you may also use a GPS-enabled mobile phone, such as a BlackBerry or Windows mobile device, with additional software to provide the same or similar functionality. Athletic use. Athletic GPS devices provide collection and analysis of athletic performance and related data. This data can be collected in a variety of ways, including one of several standardized precision athletic tests. Performance data can then be normalized based on standard or non-standard environmental conditions. These devices can help to establish a baseline of athletic ability, track progress, and provide visual data and analysis. But most importantly, these devices contain many helpful navigational tools. These tools feature backtracking modes, electric compasses, and barometric altimeters. Typically, a wearable GPS form factor is used when performing athletic activities. The most common wearable GPS models are wristbands and footpad devices. Transportation. The personal use of GPS is most often found in automobiles. The typical GPS model used in most cars will give your location, optimal routes to take, and give an estimated time of arrival. Premium models of car GPSs can record driving activity, send a text message if the alarm is going off, and even monitor car conditions such as a low battery. Global positioning systems are also making an impact on the aviation industry. While traditional radar systems are still the most widely used form of air traffic control, global positioning systems are slowly being installed in both private and commercial aircraft. Using GPS, airlines could potentially cut delays, reduce emissions by producing more accurate guidance data, and cut down on fuel costs. Future use. The next generation GPS system, Block 3A, will introduce new capabilities to meet higher demands of military and civilian users. This system is looking ahead to its first launch in 2013. Block 3A will offer the opportunity for a cross-link command and control architecture, allowing the entire GPS constellation to be updated from a single ground station instead of waiting for each satellite to orbit into view of a ground antenna. Block 3A will also support a new L1C civil signal and a spot beam antenna that provides resistance to hostile jamming while improving its accuracy and integrity.